Hey space fans, welcome back. Today, we're venturing out to the seventh planet from the Sun, the icy, mysterious world of Uranus. Now, you've probably heard that Uranus is the oddball of the solar system. While most planets spin like tops as they orbit the Sun, Uranus rolls on its side like a barrel. It has an axial tilt of a whopping 98 degrees. For comparison, Earth's tilt is about 23.5 degrees. This extreme tilt means Uranus experiences the most bizarre seasons imaginable, with each pole getting 42 years of continuous sunlight, followed by 42 years of complete darkness. So, what knocked Uranus over? The leading theory for decades has been the giant impact hypothesis. Sometime early in its history, a massive object, maybe the size of Earth, slammed into the young Uranus with such force that it completely tipped it over. It's a dramatic, cataclysmic event, and it makes a lot of sense at first. But when we look closer, this simple explanation starts to fall apart, leaving us with one of the biggest unsolved mysteries in our solar system. And that mystery is all about the company Uranus keeps. Uranus isn't alone out there. It has a whole system of rings and at least 27 moons. And here's the kicker, all of them the rings, the inner moons, the major moons, they all orbit Uranus around its equator. But since Uranus is tilted on its side, its equator is also tilted. This means the entire Uranian system planet, rings, and moons is orbiting the Sun sideways together in a neat, orderly, but completely sideways formation. This is where the giant impact theory gets tricky. If a massive object hit Uranus and knocked it over, what about the moons and the material that would later form its rings? If they were already there, orbiting in the original, upright plane of the solar system, the impact should have scattered them everywhere. Their orbits would be chaotic, tilted at all sorts of random angles relative to Uranus's new, sideways equator. But that's not what we see. We see a perfectly flat, coplanar system, just one that's tilted 98 degrees. This has led scientists to wonder, did the impact happen before the moons formed? In this scenario, the giant collision would have tilted Uranus and at the same time created a massive disk of hot gas, dust, and debris around its new, tilted equator. Over millions of years, this disk would have cooled and coalesced to form the rings and moons we see today. This neatly explains why they all share the same tilt. It's an elegant solution, right? The planet got knocked over, and everything else just formed around it in its new orientation. But even this impact-then formation idea has its own set of problems. Computer simulations of such a massive impact show that the resulting debris disk would have had a lot of material orbiting in the wrong direction, or what's called a retrograde orbit. This would create a lot of drag and instability, making it very difficult for large moons like Titania and Oberon to form. The models just can't seem to produce the stable, orderly system of moons we observe today from a single, chaotic impact event. Furthermore, there's the issue of the planet's internal heat. A collision violent enough to knock over a gas giant should have generated an immense amount of heat. Uranus should still be radiating that leftover energy into space. But when our probes measured it, they found that Uranus is surprisingly cold. It gives off almost no excess heat, which contradicts what we'd expect from a recent, giant impact. So the evidence just doesn't quite line up. The moons are too orderly and the planet is too cold. This has forced astronomers to get even more creative. What if it wasn't a single, giant impact, but a series of smaller ones? A one-to-punch or even a multi-hit scenario could have gradually pushed Uranus over without creating one single, catastrophically messy debris disk. This might have allowed the existing moon system to slowly adjust its orbital plane along with the planet, a process called precession. However, the chances of multiple, perfectly aimed impacts happening are incredibly slim. And this brings us to some even more mind-bending theories. What if the tilt wasn't caused by an impact at all? Some scientists have proposed that early in the solar system's history, Uranus might have had a very large, massive moon. Over time, through complex gravitational interactions and tidal forces, this hypothetical moon could have slowly pulled Uranus onto its side. Eventually, the same forces would have sent the moon either crashing into Uranus or being ejected from the system entirely, leaving the planet in its tilted state. Another fascinating, though more speculative, idea involves a resonant pull from a giant, undiscovered planet in the early solar system. If a massive Planet 9 type object existed and its orbit was just right, its gravitational influence could have slowly tugged on Uranus over millions of years, causing its axis to tilt. The moons would have followed suit, realigning with the planet's shifting equator. What's so exciting is that we're on the cusp of possibly solving this mystery. The James Webb Space Telescope is giving us unprecedented views of Uranus's atmosphere and rings. And there are strong proposals for a dedicated Uranus orbiter and probe mission. Such a mission would be a game changer. It could precisely measure Uranus's gravitational field, which would tell us about its internal structure. It could analyze the composition of its moons and rings, giving us clues about their origin. Did they form from the same material as Uranus, or were they captured later? Did they form from a post-impact disk? By studying the precise orbits and chemistry of the Uranian system, we could finally piece together the sequence of events. We could distinguish between a single giant impact, multiple smaller impacts, or a slower gravitational tilting process. Unlocking the secret of Uranus's tilt won't just tell us about one weird planet. It will give us a deeper understanding of how planetary systems form and evolve, and the chaotic, unpredictable events that can shape them. The solar system is full of these puzzles, and Uranus might just be the most tilted, twisted, and tantalizing one of them all. What do you think happened to Uranus? A giant cosmic collision, a runaway moon, or something else entirely? Let me know your theories down in the comments. Thanks for joining me on this journey to the outer solar system. If you enjoyed this deep dive, don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure. See you next time.